The smartest AI agents shipping into production right now aren't picking tools from a static list anymore. They are writing their own Python programs to solve complex queries independently and on the fly. On a standard uptime dashboard, a JSON-based multi-step agent looks perfectly healthy. But underneath the surface, a basic 4-step data task often triggers 5 separate round trips to the model, each one adding to the total execution time. Every time your model sends a JSON request to the tool registry and waits for a response, it consumes more tokens to reread the conversation. This repeated serialization dilutes the context, making the model more likely to hallucinate a parameter or lose track of the original goal. This friction isn't a software bug, it is a structural limit of the architecture. When an agent has to pause and report back after every single microaction, the chance for a breakdown increases with every step of the workflow. The standard JSON approach treats the model like a customer at a restaurant. It looks at the menu, orders one dish, waits for the kitchen to cook it, takes a bite, and only then decides what to order next. Code as action, or code act, turns the model into the line cook. Instead of a menu, you provide a pantry, a sandbox with importable functions where the model can execute multiple operations in a single continuous pass. It is important to distinguish the products here. A coding agent writes source code as a deliverable for a human developer. A code writing agent uses code in the background as the action format to solve any general task. In this code act method, code is no longer the final product. It is the hidden mechanism that eliminates intermediate round trips, allowing the model to perform loops and handle exceptions without asking for permission at every turn. The engine runs a tight 4-step loop: generate, extract, execute, and observe. But arbitrary code needs containment via a 5-tier sandbox. Tier 1 is in process. Production demands Tier 3, isolated micro VMs, like Firecracker, spinning up fresh environments for every session. Without an enforced hardware boundary, allowing a model to execute its own actions creates a direct path for exploits to reach your host system. Secure sandboxes have a cold start time of 200 milliseconds. To justify this cost, we must look at the total arithmetic of a multi-step task. A tool calling agent doing a 4-step task requires 4 decisions, taking over 3 seconds. A code agent collapses this into 1 call and 1 sandbox execution, taking just 1 second. At step 3, code becomes faster, ultimately using 60% fewer tokens. When tasks involve data manipulation or joining multiple sources, the reduction in overhead makes code execution the more efficient architectural choice. Code agents are not a universal replacement. For single-step lookups, voice agents requiring sub-500 millisecond responses, or rigid database entries, the simplicity of JSON tool calling is still the better fit. However, when you do use code, you face a new threat: prompts becoming shells. If an agent reads an untrusted document that contains hidden instructions, the model may execute those instructions as if they were part of the valid code block. This is a verified risk. A Cisco audit of 31,000 agent skills found that 26% of them had at least one exploitable vulnerability, usually stemming from passing unvalidated user input into a shell command. Because the prompt effectively becomes the program, every file or snippet of text the agent reads must be treated as untrusted data. To manage this, your production harness needs 4 pieces: a sandbox manager, a code extractor that validates syntax, a trace formatter for the model to read, and a policy that prevents state from leaking between different users. Security must be binary. Deny network egress from the sandbox by default. Only allow list the specific external URLs or connections the agent absolutely needs to reach. Run an A/B test this week. Take a real 4-step workflow and build it once with JSON tools and once with a code agent. Measure the success rate, the wall clock time, and the token bill for both. The shift is clear. Move away from static menus, build a secure execution kitchen, and let the model handle the composition.